Okay, welcome back to Mr. Mo's Algebra class. Today we're going to finish up the distributive property with 1-7 part 2. We're going to learn how to use the distributive property for mental math. A lot of times you guys are very impressed with how quickly I can figure out a multiplication problem. And I thank you, but it's not because I'm so special. It's just because I really understand the distributive property, okay? If you know the distributive property, multiplication becomes a lot easier. Let me explain by a simple example. Deli sandwiches cost $4.95 each. All right, what is the cost of 8 sandwiches? Well, think of it this way. You can multiply 4.95 times 8. You can. And then you could maybe mess up with the decimals or whatever. You can do that. But you're going to have to do it out longhand. Or you can solve this mentally by asking yourself, how can I arrive at the value of 495 by using easy numbers? So talk to me. How can I get to a value of 495 by using nice, easy, pretty numbers? Sir? Okay, well, if you round this to 5, it's no longer 495. Read the question. How can I arrive at the value of 495 by using easy numbers? Okay, that you're giving me a very complicated answer, and I'm saying easy numbers. Okay, no, you're not thinking. How can I arrive at the value of $4.95 by using easy numbers? Guys, sir. No, 4 times 8 is not going to get you $4.95. Yes, sir. Guys, doesn't $5 minus 5 cents give you $4.95? Then why are you guys telling me 4 times 8, 8 times 1, 4 times 1? What are we thinking about here? What was not clear? It said, how can I arrive the values of $4.95 by using easy numbers? Isn't $5 a nice, pretty number? If you subtract 5 cents, isn't 5 cents a nice, pretty number? Isn't 5 minus 0.05 $4.95? Okay. So then, how can I put this into distributive property? 8 times $5 minus 0.05. And now in my head, I can distribute. 8 times 5 is 40. 8 times 0.05 is 0.4, 40 cents. And then what's 40 minus 0.4? $39.60. That's how you use a distributive property. You have to think. You have to use your head. You cannot just sit there and look at me. Looking at me is not going to get you the answers, my friends. You really need to think about the question. I'm very surprised again that you guys kept telling me 4 times 8. How on earth does 4 times 8 get you $4.95? It's like you're not even paying attention. For example, how I use this in my everyday life, let's say I've got 8 times 26. I don't do 8 times 26. How can I arrive to the value of 26 using easy numbers? Sir. 8 times 20 plus 6. Excellent. That's what I'm talking about. Awesome. So now I can do this mentally. 8 times 20 is 160 plus 48. That's 208. That's how I do that. Yes, sir. You didn't have to go that way. You could have gone this way. 30 minus 4. And then what's 8 times 30? 240. Minus 32. Still going to be 208. There's not one particular exact answer for this. What I want you to develop is the skill of knowing factors, knowing how to add numbers together. This goes back to what I have been requesting for 4 weeks now. You must become masters of multiplication. And if you do not do that, it will hurt you for the rest of your mathematical career. I promise. Sir. Yes, sir. Sir, yes. If you multiply 495 times 8, you're going to get your answer. Yes. But I'm going to mark it wrong on the test, because I want you to show me how you got that by using the distributive property. Okay. Now, we got to figure out some new terms, okay? That means you're going to have to actually memorize them. You're going to have to actually memorize them. All of the vocabulary that we have learned in Chapter 1 is essential for the success of this whole entire year, and next year, and junior year, and senior year, I promise. That's why I take my time to make sure I teach the vocabulary correctly. First thing we got to learn about is what's called a term. A term is a number, variable, or the product of numbers and variables. Examples of terms: 2, that's a number. -6, that's a number. X, that's a variable. 2xy, that's the product of numbers and variables. 9z, that's the product of numbers and variables, okay? Now, one thing I forgot to mention, but I'll mention it right now. Terms are separated by plus or minus signs. Okay? So for example, how many terms would I have in this expression? How many terms? Yes, sir. 3. 1 term, 2 terms, 3 terms. You with me? Yes. Okay, awesome. Constant. Constant's easy. Constant is a term that has no variable. In other words, it's a number all by itself. Since it does not have a variable, the value can't change. Okay? Hence, it is constant. Constants are just numbers. 8, -9, 12, 154, 18. Constants are just numbers. Now, coefficient is the number being multiplied to a variable. So if we go back up here, 6 is being multiplied to x, correct? That's a coefficient. +3 is being multiplied to the y, correct? That's a coefficient. What would -9 be considered? It is a term, but what kind of a term? It's a constant term because it's a number by itself. Does that make sense? Awesome. Examples of coefficients would be -4x. Notice that the -4 is in purple because that's the coefficient. 18y. Notice that 18 is in purple because that's the coefficient. 2xy. Notice that the 2 is in purple because that is the coefficient. Now, like terms. Like terms are terms that have the same variable factors raised to the same power. Only like terms can be added or subtracted. For example, 8x's plus 2x's, do they have the same variable x? Are they raised to the same power? Yes, there's an invisible 1 on both, right? So you can combine those, which equals 10x. Next, negative 19xy squared minus a negative xy squared. Do they have the same variables? Are both variables to the same power? Right? X to the first, y squared, y squared. You with me? What do you do when you have a negative times a negative? That's negative 9xy squared plus 8xy squared. They are like terms, so my answer would be negative 11xy squared. Does that make sense? Okay. Now, I know that some of you are writing, but I don't have much time, and luckily this is on video. Name the terms, coefficients, and constants for each expression. Okay. What are the terms for number 1? The terms are 8x, 7y, and negative 12. What are the coefficients? 8 and 7. What are the constants? Negative 12. What are the terms here? Hold on. Okay, sorry about that little disruption. Okay, now here, for number 2. The terms here are negative 6yx, 8z, and negative 17. The coefficients, call it CF, are negative 6 and 8. And the constants, we'll call them CT, is just negative 17. Okay, next, number 3. The terms, it's just one term here, negative 12xyz. The coefficient, CF, 0. There is no coefficient. And last but not least, CT, the constant, there is none. There are no constants. Okay, number 4. The number of terms, there are 2 terms, 22 and 12y. So 22 and 12y. The coefficient, CF, is 12. The number being multiplied to the variable. And 3, CT, is the constant, which is 22. Okay? And now, the last skill that we need is to combine like terms. Okay, number 1, I have 8x squared plus 2x squared. They are like terms because they have the same variable raised to the same power. So that's going to be 10x squared. Number 2, 5x and negative 3x are like terms. So 5x's minus 3x's is 2x. Okay. Then I have a 6y that's by itself, so plus 6y. And then I have a negative 3 and a 4. Those are numbers. Those are like terms. So that would be 2x plus 6y plus 1. And number 3, I have negative 7nm to the 4th minus 5nm to the 4th. Negative 7nm to the 4th minus 5nm to the 4th. The signs are the same. You add and keep the sign. Negative 12nm to the 4th. Done. For number 4, n and negative 17n are like terms. 1 minus 17, the signs are opposite. So you subtract as normal and keep the sign of the largest absolute value. So that's negative 16n. And then I have a positive 5 and a positive 3. 5 plus 3 is 8. Thank you very much for a great class. I hope you learned a lot. God bless you and take care.